Welcome to GyanPub. Today, in this session, we are going to learn about the chapter Chemical Reactions and Equations. So, in this chapter, we are going to cover the following objectives, and they are Introduction to Chemical Reaction, Chemical Equations, Balancing the Chemical Equations, Types of Chemical Reactions, and Oxidation and Reduction. So, now let us discuss about the introduction to chemical reaction. So, in our daily life, we observe many changes like grapes getting fermented, rusting of iron, washing of clothes, digestion in our body, and respiration process. So, we observe many changes like these in our everyday life. So, in all these changes, we observe that the initial identity, the identity of the body is changed at last. So the initial identity is changed in this process. So we can say that there a chemical change is occurring. So whenever a chemical change is occurred, we can say that a chemical reaction has taken place. So we can define chemical reaction as a process in which one substance transforms into another substance with new properties, then it is a chemical reaction. So one substance will get transformed into another substance by changing its color, by changing its temperature, or by changing its physical conditions, or changing its chemical properties. Then the process involved in these changes is a chemical reaction. So, for example, rusting of iron. So, if iron is exposed to moisture atmosphere, then it is getting oxidized and it gets rusted. So, here we can see the diagram of iron nails which are exposed to moisture atmosphere and which got rusted after some days. So, after some time, their chemical nature is changed, and the process here is a chemical reaction. And we also observe respiration in our body, like we inhale oxygen and we leave carbon dioxide. So the process of converting oxygen into carbon dioxide in the body is also a chemical change, and there in our body chemical reaction taking place. So we also observe many changes like fermentation of grapes and removal of stains after washing the clothes, etc. In this session, we are going to learn about how to determine whether a chemical reaction has taken place or not. We say that we observe many chemical changes in our life, and we observe many chemical reactions taking place in our life. But how can you determine that there a chemical reaction has taken place or not? So there are some chemical changes by which we can conclude that a chemical reaction has taken place. So they are change in state. Whenever we observe the change in state of the initial substance, that is changing its states from solid to liquid or gas, or liquid to solid or gas, or gaseous to solid or liquid, etc. etc. Then we can say that there a change in state is occurred, and if a change in state is observed, then we can say there a chemical reaction has taken place. So, for example, melting of ice. So, solid ice is getting converted into liquid. So, in this figure, we can see that the ice is getting converted into liquid. So, here the solid state is converted into liquid state. So, we can say that here a chemical reaction has taken place. And if we observe change in color of the initial substance, then we can say that there a chemical reaction has taken place. So, for example, rusting of copper. So, in the process of rusting of copper, the initial color was brown, and after getting rusted, it changes its color into green color. So here we can observe a copper which got rusted, and there we can observe a color change which indicates chemical reaction. And evolution of gas. If in a process or if in a chemical chain, if we observe the gases evolved from that, then we can say there a chemical reaction has taken place. We observe the evolution of hydrogen gas in the reaction of dilute sulfuric acid and zinc. So there chemical reaction has taken place. So here there is a flask in which dilute sulfuric acid and zinc granules are there, and after getting reacted, H2 gas is escaped from this. So here a chemical reaction has taken place, which is indicated by the evolution of hydrogen gas and change in temperature. So if we observe change in temperature of the body from its initial condition, then we can say that there also a chemical reaction has taken place. So this is an image of cooking rice where the initial temperature is changed and rice is formed after changing its temperature, where a chemical reaction also taken place. Now let us discuss about what is a chemical equation. So we observe many chemical changes and we observe many chemical reactions in our life. So if we identify that a chemical reaction has taken place at a particular time, then we need to describe what is the chemical reaction taken place. So if we observe any change in color or change in temperature or evolution of gas or change in state of any substance, then we can say that there a chemical reaction has taken place. So if we observe chemical reaction has taken place, then we need to describe that chemical reaction. So there we use chemical equations. So we can simply say that a chemical equation is the simplest way of describing a chemical reaction. So a chemical equation consists of the reactants and products with an arrow mark indicating that reactants got changed to products. It is the simplest way of describing a chemical reaction. If we consider the reaction that magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. So if magnesium is reacted with oxygen, then it is converted into magnesium oxide. So in this reaction, magnesium and oxygen are the reactants and magnesium oxide is the product. So the change we explain, the change we describe here is represented in the form of chemical equation. These are the reactants which are on the left side of the equation by a plus symbol in between them, and this MgO, that is magnesium oxide, is the product which is on the right side, and if there are extra products, then we can put the products in the right side by putting a plus symbol between them, and we need to provide an arrow mark between the reactants and products which indicate the change of reactants to products. That is, so a chemical equation represents the identities and relative amounts of reactants and products in a chemical reaction. So how much amount of the reactants are used and how much amount of product is obtained is described in a chemical equation, and what are the identities to be used and what are the substances which are used. Everything is explained in a chemical equation. So we describe a chemical reaction in a chemical equation. So here we observe a diagram of heating magnesium ribbon and it is getting powdered to magnesium oxide and the powder is collected in a watch glass. So here Mg is combining with oxygen, that is here magnesium is combining with oxygen and it is giving magnesium oxide. So these reactants react with each other and give products, which is explained in a chemical equation. Now let us discuss about how to write a chemical equation. So we said that chemical equation is a simple way to describe a chemical reaction. A chemical reaction taken place can be described in a sentence form. If we consider the example of magnesium ribbon heating, that is, if a magnesium ribbon is heated under oxygen, it gives a magnesium oxide powder. So it can be described in a sentence form like when a magnesium ribbon is heated under oxygen, then it is giving magnesium oxide. Explaining this reaction in the sentence form is quite long. So this description can be made in a simpler way by using different types of equations. That is, there are two simplest ways to write a chemical equation and they are word equation. The word equation is using the words of the chemicals involved in a reaction. That is, a word equation for the same example of magnesium ribbon heating under oxygen is when a magnesium ribbon is burnt in oxygen. So the word equation for the reaction when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide is magnesium plus oxygen gives rise to magnesium oxide. So in this equation we are involving the words of the chemicals involved in the reaction and the reactants are on the left hand side of the equation and the products are on the right hand side of the equation, and the reactants are added with the plus symbol on the left hand side of the equation, and if there are more than single product, then the products are also to be added on the right hand side of the equation by including a plus symbol between them, and an arrow mark indicating the direction of reaction and indicating that the reactants are converted into products. So an arrow mark is used in between this reactants and products. So if we consider still a shorter way to write a chemical equation, then we make use of chemical formulae. We need to write the equation using chemical formula. So chemical formula of the chemical substances involved in it instead of words. So we need to write the equation using chemical formula. This is a more shorter way and more simplest way to represent a chemical equation. So here we are using the chemical formula of the chemical substances involved in the reaction instead of the words. So for the word equation of magnesium plus oxygen giving rise to magnesium oxide, the equation using chemical formula can be written as Mg plus O2 gives rise to MgO, that is magnesium. The chemical formula of the magnesium is Mg and the chemical formula of oxygen is O2 and the chemical formula of magnesium oxide is MgO. So involving all these chemical formula in the equation, then we get the description of the reaction of magnesium which is burnt in oxygen, that is magnesium plus oxygen which gives rise to magnesium oxide. So this is the word equation, and according to the law of conservation, the energy and cannot be destroyed, or energy cannot be created. So the composition or mass which is in the reactant side should be equal to the composition or mass which is on the product side. So we need to balance the equation, and the balanced equation for the magnesium burnt in oxygen is 2 times Mg plus oxygen gives rise to 2 times magnesium oxide. That is 2 times magnesium plus oxygen gives rise to 2 times magnesium oxide. And if we see here, there are 2 molecules of magnesium, 2 molecules of magnesium. So if we see that there are 2 moles of magnesium and 2 moles of magnesium both on reactant and product side, 2 atoms of oxygen and 2 atoms of oxygen in both reactant and product side. So here you can see the diagram of magnesium ribbon burning in oxygen. So here we are describing this equation in the form of word equation, and to make it more simpler way, we are using chemical formulae to describe this equation. So we are describing this reaction in the form of a chemical equation, and if we use a word equation, we need to use these words, and to make it more simpler and shorter way, we need to use the equation using chemical formulae of the chemical substances involved in it. So here magnesium is burning in oxygen and is giving magnesium oxide powder.
Now let us discuss about balancing the chemical equation. So why do we balance chemical equation? According to law of conservation of mass, no energy or no atom or no mass is neither created nor destroyed in a chemical reaction. So the number of atoms that are present in the reactants has to balance the number of atoms that are present in the mass products. So the total mass in the reactant side should equalize to the total mass on the product side. So that is why we need to balance the chemical equation. So it is important to balance the chemical equation. And how to balance a chemical equation? So to balance a chemical equation, there are some steps to balance any chemical equation which is unbalanced. So this method is called as hit and trial method, and if we consider the equation, that is the reaction between iron and water, that is Fe plus H2O gives rise to Fe3O4, that is ferric oxide and hydrogen. So this is an unbalanced equation, and we are going to balance this equation using the steps. So the first step is to list the number of atoms of different elements present in the unbalanced equation. So if we list the number of atoms of different elements present in the unbalanced equation, here we have iron atoms, that is Fe atoms. On left hand side there are 1 atom and 3 atoms on the right hand side, and hydrogen, there are 2 atoms on the left hand side and 2 atoms on the right hand side, and oxygen, there is 1 atom on the left hand side and 4 atoms on the right hand side of the equation. So now the second step is start balancing the compound which has maximum number of atoms and select the element which has maximum number of atoms. So there are maximum number of atoms in the compound ferric oxide. There are 7 number of atoms, and in that the element oxygen has 4 number of atoms. So it has maximum number of atoms. So 4 number of oxygen elements are there. So 4 atoms of oxygen element are there, and first we have to balance the maximum number of atoms of an element in the compound which has maximum number of atoms. So balancing oxygen, we need to put 4 before H2O, that is water, in the left hand side, so that we get Fe plus 4 H2O gives rise to Fe3O4 plus H2. So here now again listing the number of atoms, iron is iron has one element on the left hand side and three elements on the, so there are one iron atom in the left hand side and three iron atoms on the right hand side, and 8 hydrogen atoms on the left hand side and 2 hydrogen atoms on the right hand side, and there are 4 oxygen atoms on the left hand side and 4 oxygen atoms on the right hand side. So the oxygens are balanced now. And going to the step 3, select the next element and balance it. So if we select the next element from this equation, then we have to balance hydrogen from this equation. So to balance hydrogen atoms, put the coefficient 4 between H2 in the right hand side, so that we get Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So again analyzing the list of number of atoms of different elements present. Now we have one iron atom in the left hand side and 3 iron atoms on the right hand side, and 8 hydrogen atoms on the left hand side and 8 hydrogen atoms on the right hand side, and we also have 4 oxygen atoms on the left hand side and 4 oxygen atoms on the right hand side. So we have hydrogen and oxygen balanced with 8 hydrogens on both LHS and RHS, that is left hand side and right hand side, and 4 oxygens on both right hand side and left hand side. So, and the next step is to balance. Similarly, we need to balance all the other elements one by one, so that there is no change in previously balanced element. So the previously balanced elements are hydrogen and oxygen. So we need to select the next element to balance, but we should not change the previously balanced elements, that is hydrogen and oxygen. So selecting iron to balance. Now there are 3 iron atoms on the right hand side of the equation. So to balance the iron, we need to put 3 before the iron in left hand side, so that we get 3 Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So now again at last check the equation whether it is balanced or not. So if not, then balance the element which is not balanced. So now we are going to check this equation which it is balanced or not. So there are 3 iron atoms on left hand side and 3 iron atoms on the right hand side, and there are 8 hydrogen atoms on the left hand side and 8 hydrogen atoms on the right hand side, and there are 4 oxygen atoms on the left hand side and 4 oxygen atoms on the right hand side. So the equation is balanced with equal number of atoms of each element on both left hand side and the right hand side. So here, according to the law of conservation of mass, the equation is balanced and total number of atoms are equal on both sides. So after balancing the equation, the last step is to make the equation more informative with the symbols of physical states to be balanced equation. So we need to put the symbols of physical states to the balanced equation. So there is a diagram of physical states here. So for solid, we need to put a bracket with S in it. So S symbol represents the meaning solid, and L symbol represents the liquid, and G symbol represents the gas, and AQ symbol represents the aqueous solution dissolved in water. And for gas forms which are evaluated, the upside arrow is should use, and precipitate which forms down, we need to use downside arrow. And for symbolizing the reaction from reactants to product, we need to use an arrow mark that is headed right side, which means produces or yields, and the reaction in which products can reform into reactants, or reactants are used to produce products and products are used to produce the same reactants, then we need to use this arrow mark. And if heat is applied in the reactant side, then we need to use the delta symbol on the arrow mark. And if there are any other conditions like temperature, pressure and etc., we should indicate them on the arrow mark and then write the equation. So writing the equation with the symbols for this equation, we have 3Fe, that is iron is in solid state, so we used S here. So iron in solid state when reacted with water which is in gaseous state. So 3Fe brackets S plus 4H2O, which is in gaseous state, we need to put gas C, on reaction gives rise to ferric oxide, which is a solid again, so we need to put bracket in between S in between brackets, and 4H2, 4 hydrogen, 4 times hydrogen gas, so gas we need to put gas symbol again G. So the equation here is more informative, so we can say that solid iron when reacted with the gaseous water gives rise to solid ferric oxide plus hydrogen, which is a gas again, and here it is totally balanced and it is a perfectly balanced equation. So balancing the equation using these steps makes easier.
So now let us discuss about the types of chemical reactions. So what are the chemical reactions and what are their different types and examples for those all types. So here the different types of chemical reactions which we discuss are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, exothermic and endothermic reactions, and oxidation and reduction reactions. So we know that no mass is neither created nor destroyed. So mass is neither created nor destroyed. So if in a chemical reaction which is taken place, there no mass is entered or no mass is gone out of the reaction. So there the substances make bonds between them or dissociate bonds between them, and due to this type of making or dissociating or displacing or anything between themselves, there occurs the different types of chemical reactions. So let us discuss about these chemical reactions, and now let us discuss about combination reaction. So a combination reaction is a reaction in which a single product is formed from the multiple products. That is, if two or more products combine together to form a single product, then it is called a combination reaction. So there two or more substances are combining, they are combining together to form a single product. So this is called as a combination reaction. So the general form of this type of reaction is if A plus B gives rise to AB. So A and B combine together to give the product AB, then it is called a combination reaction. So in this reaction we can observe that two or more compounds combine to give a single compound. For example, we consider a table salt, that is sodium chloride. So sodium, whose chemical formula is Na, and chloride, whose chemical formula is Cl, combine to give sodium chloride, that is NaCl. So sodium and chlorine combine together to give sodium chloride, and this is a combination reaction. And here we can see the diagram of sodium metal and chlorine gas, which both combine together and give the table salt. So here in this equation, this bracket S in brackets represent the physical state of the sodium, chlorine and sodium chloride, that is, they are solids. And another example for the combination reaction is burning of coal, that is carbon. C is the chemical formula of carbon, which is combining with oxygen to give carbon dioxide gas. So here two components are combining together to give a single component in the product. So two multiple components combine together to form a single product, then this type of reaction is called combination reaction. Now let us discuss about the decomposition reaction. So decomposition reaction is a quietly opposite reaction to a combination reaction. So in a combination reaction, two or more reactants combine to form a single product. But in a decomposition reaction, a single reactant is breaking into the different products, into multiple products. So if in a reaction, if a single reactant breaks down to give multiple products or simpler products, then it is called a decomposition reaction. Here, a complex substance which is single is breaking down to form simple products, and the general form of this type of reaction is AB gives rise to A plus B. So here AB is a single product and it is separated to A and B in the products, and this type of reaction in which decomposition is taking place, this is called as decomposition reaction. So here the complex substances are breaking to give more than one compound. So we obtain more than one compound from a single compound. For example, decomposition of calcium carbonate, that is, on heating calcium carbonate we get calcium oxide and carbon dioxide. So calcium carbonate chemical formula is CaCO3 and calcium oxide is CaO and carbon dioxide is CO2. The single calcium carbonate compound is breaking down to give calcium oxide, that is quicklime, and carbon dioxide, two different products. So here the single compound is breaking down to give two products. This is called a decomposition reaction. It represents the diagram of heating calcium carbonate and obtaining calcium oxide and carbon dioxide here. So here this is a diagram which explains the decomposition reaction of calcium carbonate. Another example is decomposition of ferrous sulfate. So decomposition of ferrous sulfate gives rise to ferric oxide and sulfur dioxide and sulfur trioxide. So here one single substance is converting to three different products. So this is an example for decomposition reaction.